Hello friends, in this problem you have been given an exponential equation and you have to solve for x. That is, what is the value of x that satisfies this equation. And the equation is you have 3 raised to the power x plus 4 raised to the power x plus 5 raised to the power x, and this is equals to 6 raised to the power x. So how will you solve this problem? So what I can do is I can divide both sides by 6 raised to the power x. Each term I can divide by 6 raised to the power x. Now the right hand side will become simply 1. So this is 3 raised to the power x divided by 6 raised to the power x plus this thing 5 raised to the power x divided by 6 raised to the power x is equals to 1. Now you can use rules of power, that is, if you have a raised to the power m divided by b raised to the power m, this can be written as a by b raised to the power m. So if I use this rule, I can write this is 3 by 6 raised to the power x plus 4 by 6 raised x, and this is 5 by 6 raised x. I can further simplify. This becomes 1 by 2 and this becomes 2 by 3, and this will remain as it is, that is 5 by 6 raised to the power x is equals to 1. Now what should I do next? So what I will do is I will find solution of this equation by inspection, and then we will prove that this equation has only one solution. So let us try to see what I want to say. Let us say this part of this equation is fx and this is gx. This means I can say fx is equals to this function 1 by 2x 2 raised to the power 2 by 3 raised to the power x 5 by 6 raised to the power x, and gx is simply 1. Gx is a constant function. Gx is equals to 1. Now let us investigate monotonicity of fx. That is, fx is an increasing function or decreasing function, and this can be done by differentiation. So if you differentiate fx, if it is greater than 0, this means this is an increasing function, and if this is less than 0, this means this is a decreasing function. So let us differentiate this, but I will use one result of differentiation, that is this result, d by dx of a raised to the power x, this is equals to a raised to the power x ln a. So let us use this result. So now I can write f dash x is equals to, so using this result I can write 1 by 2 raised to the power x ln 1 by 2, and the second term, differentiation of second term, this is 2 by 3 raised to the power x ln 2 by 3, and the differentiation of third term 5 by 6 raised to the power x ln 5 by 6. Now what can you say whether this f dash x is positive or negative? You see this term 1 by 2 raised to the power x, this term will be positive. For any x this is a positive quantity, but this quantity log of 1 by 2, that is a number between 0 to 1, log of that number is negative. So this is a negative quantity. Similarly, this is a positive quantity and this one is a negative quantity. Positive, and this is negative. This means each term is negative. So overall I can say f dash x is a negative quantity. This means this is a decreasing function. So I can conclude from here that fx is a decreasing function. So if you plot a graph of f dash x, how this will look like? So this is my x-axis and this is my y-axis, and you can calculate what is the value of fx at 0. So let us find what is the value of f0, because this term will be 1 by 2 raised to the power 0, that is 1. This is also 2 by 3 raised to the power 0, that is 1. This term is also 1. So 1 plus 1 plus 1. So f0 is 3. So let us say 3 is somewhere here. And this is a decreasing function. This means this fx will go something like this. So this is my fx. And this point will be 0, 3. Now let us plot another function, that is gx. Gx is equals to 1. So how will you plot? So this is a constant function and you will have something like this. So this is my gx. And you can clearly see these two are basically crossing at one point. And this is the point of intersection. This is the solution. Now let us find this point by inspection. So we will start from 0 and then we will keep going and we will see when fx is equals to gx. Or it satisfies the original equation. So what was the original equation? Original equation was you have 3 raised to the power x plus 4 raised to the power x plus 5 raised to the power x, and this is equals to 6 raised to the power x. Let us start with x equals to 0. So we will have 3 raised to the power 0, 4 raised to the power 0, 5 raised to the power 0, which is equals to 3 because each power 0 is 1. Is this equals to 6 raised to the power 0? No, because 6 raised to the power 0 is 1. So left hand side is not equal to right hand side. So this does not satisfy this equation. So x equals to 0 is not a solution. What about x equals to 1? This side we have 3 raised to the power 1 plus 4 raised to the power 1 plus 5 raised to the power 1. This is equals to 7 plus 5, 12. Left hand side is 12 and right hand side will be 6 raised to the power 2. This is 36. So left hand side is not equal to right hand side. So this is also not a solution. What about x equals to 2? So this becomes 3 square plus 4 square plus 5 square. So this is 9 plus 16 plus 25, which is equals to 50. And what about, okay, so in this case, this was 6 raised to the power 1. This is not 36, this is 6. And there you will have right hand side 6 raised to the power 2, that is 36. 50 is not equal to 36. So this is also not a solution. What about x equals to 3? So 3 raised to the power 3, 4 raised to the power 3, 5 raised to the power 3. So first is 27, 64 plus 125. And this is equals to 216. Now what about right hand side? Right hand side you have 6 raised to the power 3, 6 into 6 into 6, that is also 216. So this is also equals to 216. So now I can say left hand side is equals to right hand side. So x is equals to 3 is basically a solution of this equation. So x equals to 3 is a solution, and we have proved that this equation will have only one solution. Now to illustrate this graphically, I have plotted these two graphs. So the fx was, if you remember, that was 1 by 2 raised to the power x, 2 by 3 raised to the power x, 5 by 6 raised to the power x. So I have plotted this graph. So this function is your fx. So this is going like this. This is your fx. And gx is simply 1. So we have plotted this function. So this function is gx. So you can see this function is gx. Now fx and gx are basically crossing at this point. And this point is x coordinate is 3 and y coordinate is 1. So this means x equals to 3 is a solution. At x equals to 3, what is the value of y? Y value is, that is the value of fx, is equals to 1. And the same time gx value is also equals to 1. So I hope you enjoyed this video, and if you enjoy, please share with your friends, like this video and subscribe to my channel.